day to you all there. I hope you are doing great out there. That is very good. Today we'll be focusing our class on sequence, series, arithmetic projection, and geometric progression. We'll be looking at this set of topic one after the other. We'll first of all be looking at sequence and series. What is meant by sequence? Sequence is defined as the succession of terms in which each successive terms are differ to one another in a well-defined rule. That is, the terms are differ to one another. They are arranged in the form by which they can be different to one another in a well-defined rule. That is, if this one is different by a particular difference, the next one will have the same difference equal to it. The next one will also have the same difference, or they can be either in arithmetic progression difference or in a geometric progression difference. Now, let's look at a very good example of a sequence. If I have a kind of arrangement of terms in this order 2, 5, 8, 11. This is a very good example of a sequence. If you look at this very well, you discover that the difference between these 2 and 5 is 3. The difference between 8 and 5 is 3, while the difference between 11 and 8 is also 3. So there is difference between the successive terms. The one that succeeds this one is 5. 5 succeeds 2, 8 succeeds 5. The difference between them is well defined. That is how we define sequence. Now, what is meant by series? Series is the addition of sequence terms. When you now add these terms, whatever terms that is given to us as the terms of sequence, when we add it together with one another, we call such a set of arrangement, we call it a series. For example, if you have a series can be in this form 2 plus 5 plus 8 plus 11. When you have this addition coming in between these terms, you call it that kind of arrangement, you call it a series arrangement. Now, let's look at some question as regard sequence and series and how we can as well deal with this set of questions stating. Questions we have here ask us to find the first 3 terms of this set of sequence. Let's look at how we are going to solve it one after the other. Now, the first question here says that we should look for the terms of 3 and plus 1. Now, the first term, n is the number of terms. Take note of that. N is equal to number of terms. Now, for the first term, wherever you see n there, you put 1 there. So for the first term, n is equal to 1. Therefore, the term will be 3 multiplied by 1 plus 1, which is equal to 3 plus 1. It gives us 4. That is the first term. For the second term, n will be equal to 2. So where for the second term, this sequence will be 3 multiplied by 2 plus 1, which is equal to what? 6 plus 1, which is equal to 7. The third term, where n will be equal to 3 there, is equal to 3 multiplied by 3 plus 1. Look at the way the expression goes there. That will be equal to 9 plus 1, which is equal to 10. That is the set of the first, second, and third term for these sequence terms here. So we have you can now say that the terms are 4, 7, and 10. Those are the terms of the sequence that we have there. For this second expression that we have here, the sequence that we also have there says that n all over n plus 1. We are asked to find the first, second, and the third term of this sequence as well. For the first term, where n is equal to number of terms, for the first term, n is equal to 1. So wherever we see n here, what you put there is 1. This one will be 1 over 1 plus 1. That will be equal to 1 over 2. This is the first term value. For the second term, n will be equal to 2 in the second term. Where for inserting that 2 into this expression will be 2 over 2 plus 1, which is equal to what? 2 over 3. That is the second term as well. While the third term, where n is equal to 3 there, it will be equal to 3 over 3 plus 1, which is equal to what? 3 over 4. So the expression for the third term is equal to 3 over 4. Therefore, we have the first, second, and third term to be 1 over 2, 2 over 3, and 3 over 4. Those are the value of the first, second, and third term for that sequence as well. Then for the third question that we have there, which is 16 multiplied by 2 raised to the power of minus n. For the first term, don't forget, whenever you see n, is a term that you are going to put there. Where we know that n is the number of terms. So in the first term, n will be equal to 1. When n is equal to 1 in first term, so we are going to have the expression to become 16 multiplied by 2 raised to the power of minus 1. Now, in mathematics, we all know that when we have a negative index, or you can call it negative power expression like this, that a negative value means reciprocal of such a value that we have there. So, which means here that this one will become 1 over 2 raised to the power of 1. So it becomes 16 multiplied by 1 over 2 raised to the power of 1, which is equal to 16. 16 times 1, 16 all over 2. 16 over 2 will be equal to 8. That is the value of the first term there. For the second term give us n is equal to 2 there. We have to insert the value there. 16 multiplied by 2 raised to the power of minus 2, which will give us 16 multiplied by 1 over 2 raised to the power of 2. Don't forget that I have told you earlier that the negative value that is at this power here will become the reciprocal of the expression there. So the 2 over 2 raised to the power of 2 that we have there, that negative value just comes as a reciprocal to that value. So we are having 16 times 1, 16, because this one is as well equal to over 1, all over 4. 2 raised to the power 2 is 4. That will be equal to 16 raised over 4 is equal to 4. That is also the answer to the second question there. For the third term, n will be equal to 3 there. When n is equal to 3 there, 16 multiplied by 2 raised to the power of minus 3 will become 16 multiplied by 1 over 2 raised to the power of 3. What is the value of 2 raised to the power of 3? That will be equal to 8. So we are having 16 all over 8, which is equal to what? 2. So for the first, second, and third term of this sequence expression here will be equal to, the first term is equal to 8, second term is equal to 4, and the third term is equal to 2. 8, 4, 2. So we have this set of answers to the question that we are asked to find here. So if you have a related question that looks like this. That is how you provide the answer to it. We have some other relevant question that will also increase your knowledge about the sequence and series. Stay tuned. Question we also have here, another one we have here. This question here say that we have been given the value of the sequence for this expression. We're asked to find the value of the 12th term. 12th term for the first one, we are asked to find it for the n squared minus 1, and the second one we will find it underneath a. Now, for you to find the value of this one, you can see that it is a 12th term they are asked us to find. That's the 12th term. So there, n is equal to 12. When n is equal to 12, then you now see 12 raised to the power of 2 minus 1. That is what you just said here, which is equal to, what's the value of 12 raised to the power of 2? That is 12 times 12. That will be 144. 144 minus 1 give us 143. That is the answer to this expression here. Now, for the second question that we have here as well, the second question says that we should find the value for 3 minus 5n for T12, for 12th term, for the 12th term. So don't forget that I have told you that the number of terms is the value of n. Now, which means that here n is equal to 12. Here we are going to say 3 minus 5 multiplied by 12, which is going to give us 3 minus 4. 5 multiplied by 12 will give us 60. 60. So 3 minus 60 will give us minus 57. That is the answer to that question. That's how you solve such a question. Now, for the other question that we have here, the expression says that we find the 8 terms. You can see this means 8 terms for 512 multiplied by 2 raised to the power of minus n. 2 raised to the power of minus n. So, how do we go about this expression? I've told you earlier that n is the number of terms. So, the number of terms here is equal to 8. So, wherever you see n here, you put 8 there. So, we are going to have T8, which is equal to 512 multiplied by 2 raised to the power of minus 8 now. So, which is going to be equal to 512 multiplied by 1 over, don't forget, I have earlier told you that when you have a negative value at the power level here, it's going to turn into a reciprocal of that particular term, 2 raised to the power of 8. So this becomes 512 multiplied by 1 over 2 raised to the power of 8 will give us 256, which is going to now be equal to 512. When you multiply 512 by 1, you get 512. Then the value we have here, this one is as well equal to over 1. 1 times 256 will be equal to 256. If you divide it with one another, 256, 512 divided by 256, you are going to get 2 as the answer of that question here. That is how you deal with this kind of a question. Do stay tuned for the next question and the formula. Now, in the question we've been doing so far, we are asked to provide the particular value of a particular term. But in this case now, we are asked to provide the formula that gives the expression of those terms that we are given here. Now, let's look at how we are going to solve this kind of question. In this case now, for the first question number 1 here, we have the terms to be 2, 4, 6, 8. Those are the terms. This is the first term, this is the second term, this is the third term, and this is the fourth terms. Now, let's now look at those terms one after the other. When we look at those terms one after the other, you are now going to see how they are related with one another from that we'll be able to find the right formula we can give to these terms expression we have here. Now the first term is equal to 2. The term 2, that is the second term, is equal to 2 plus 2. You can see that if I look at these terms very well that we have here now, I will say this is a forms of addition of 2 to the first term that we have here. So the third term as well will be equal to 2 plus 2 plus 2. Because it is 6. When you have this together, you as well get 6 here. Now, after that, the fourth term, T4, is equal to 2 plus 2 plus 2 plus 2. That is equal to 8 as well. Now, when you look at the value of each terms very well, each of these terms very well, you will discover that these two are common to all these terms. It's common to all the terms that we have here. So we can now say that, okay, for the formula of the term, we have 2 is common to all of them. Then the number of terms in which each of them belong to. Let's look at it. This is the first term. How many 2 do we have there? We have just only 1. So we can easily say that this is 2 multiplied by 1. If you look at the second term very well, this is what? We have how many 2? 2. That is got what? 2 multiplied by 2. Look at this third term. That's what? 2 multiplied by 3. Likewise, the same thing is going to be applicable to the fourth term as well. Now, if you look at the value that I multiply each of these term by, you will discover that it is the value of the term that they belong to. In this case now, I can easily say that the formula for my term is 2n. That is 2n, which means I can now say that Tn is equal to 2n. That is the formula for my sequence term is 2n. This question as well take us to the next question. We have the sequence to be 0 minus half, as we have it here, minus half, 1, and we also have minus 1. We also have minus 1 number 1 over 2, 1 whole number 1 over 2. So these are in except this first term here, that is the positive value there. Now, if you look at this set of expression very well, one thing is common to them, that is the negative values there. Since this is 0, it might not be what we are going to give a consideration about, because 0 does not have either a positive or negative value. So for the first term now, T1 here will be equal to 0, as we have it here, as we have it in the first expression there. Where T2, as we can see, what is the answer to T2 there? T2 can be equal to 0 minus 1 over 2. You can say plus minus 1 over 2. You are still saying the same thing. Now, the third one there will be equal to 0 minus 1 over 2 minus 1 over 2 minus 1 over 2 minus 1 over 2 there. Here, T, for that is the fourth term here, is equal to 0 minus 1 over 2 minus 1 over 2 minus 1 over 2. You can see we are having how many negative half here? We are having 3 negative half here. Now, for you to get the formula for this kind of question we have here now, let's look at what is common to all these terms. Except this first term that we have 0 there. The remaining terms, all of them, what the value that's common to them is 1 over 2. So common value is equal to 1 over 2. Do not say minus 1 over 2. Where that negative value is going to come in, you are still going to see it. Now, the value that is common to all of them is minus 1 over 2. I take 1 over 2 as a common value to them. Now, after that, I will now look at what is that thing I will add. Well, am I going to add or am I going to multiply a particular value to it to be able to get all this expression for each of the terms? Now, if I look at it very well now, I can now say that, okay, 1 over 2 is common to them. Here, we have how many of the 1 over 2? In the fourth term, we have 3 1 over 2 there. In the third term, we have how many 1 over 2? 2 1 over 2. In the second term, we have what? We have 1 1 over 2. In that sense, it means that each of the terms, the value that we have here has been reduced by 1. That is, that will be equal to what? 1 minus, because we are having negative value there, 1 minus n. Now, that is, each of the terms has been reduced by 1. You can now see that here we are going to have minus 1 over 2, which is minus 3 over 2. Here we are going to have minus 1. Here, so when you make use of this expression and come in here, you are going to get that your value like that. Don't take note of what we did here. The common value to them is what? 1 over 2. Now, for each of the expression, look at the value, each of those common value. How many times do they exist? At each of the terms, we discover that they exist in the number that makes the term to be reduced by 1. Here, instead of it to exist 4 times, it exists in how many times? It exists only in 3 times, which has reduced the number of times by 1. Here also, which is the third term, it exists only 2 times. The same thing applies to the second term as well. So now we now have the formula where we have Tn is equal to what? R into bracket 1 minus n. Why do we have 1 minus n? Is that by the time you put these 1 minus 1 over n and you multiply it by with this value at this outside this bracket, you discover that you are going to get a negative value. Don't forget that all this expression, each of the terms are of the negative expression. Let's take, for example, I want to take one of these particular question as a case study, as one of the term as a case study. I'm taking the fourth term now. You can see that this is the first, second, third, and fourth term. I'm taking the fourth term into consideration now. T4 will be equal to half into bracket 1 minus 4. 1 minus 4 is equal to what? That's what? Half into bracket minus 3, because 1 minus 4 will give us minus 3. You know, this one is as well equal to 1 over 2 multiplied by minus 3 over 1. It's equal to what? Minus 3 over 2. Now, this is the answer that is correct with this expression that we have with this first term we have here, which is the expression of minus 1 over 1 over 2. You know that if you convert this particular value into a fraction, you get 2 times 1, that's 2, plus 1, that's 3 over 2, and which is going to be negative as well. So if you apply this formula into any of this term here, you will get each of them appropriately. So that is the formula that is going to be the value of that particular expression. This is for this and that is for that. Stay tuned for the next question. This question we have here as well is different to the question we'll be having so far. The question says that if Tn is equal to this that particular sequence expression, that is 2 minus 3n, it says that which particular term is minus 58. We have Tn which is equal to what? 2 minus 3n. That is a sequence expression. Now, which term is minus 58? We are not given the number of terms. We are only given the value of that particular expression that gives us this. So we can now say that 2 minus 3n is equal to minus 58, equated to that particular value given to us, in order for us to get the value of our n here. Now, so let's try to make n subject of formula. Now we are going to have 2 minus 3n, which is given to be minus 58, I've repeated it again. We can now say that we have to subtract 2 from both sides. So we have 2 minus 2 minus 3n is equal to minus 58 minus 2. That will be equal to, this one cut each other, minus 3n is equal to minus 60. Minus 3n will give us minus 60. Where minus, we are now can now say that for us to find the value of n alone, you now say divide both sides by minus 3. We are having minus 3n over minus 3 is equal to minus 60 over minus 3. You know, we cut this like this, you discover that it is only n that will remain here. Negative here, call this negative value here. 60 divided by 3, that will be equal to, where n now will be equal to 20. So that is the number of terms that will give us this, make this expression to be equal to minus 58. Now, let's do this again. Let's try to insert this 20 into where we have this n here. We have 2 minus 3 here. 2 minus 3 multiplied by 20. That will be equal to what? 2 minus 60. That will be equal to minus 58. So that expression is quite correct and very good for the question we have solved. That question and many other questions are of the nature that they come in different form as a trick for students. Please do take note of how we have been solving it so far and stay tuned for the next question. This question we have here, I want to read the question now. In a sequence given by Tn, that is the number of terms, the sequence terms is equal to a plus bn. The 7th and 15th term are 19 and 43 respectively. Find the value of a and b. Find the value of a and b. We have been given the 7th and the 15th term. The 7th term is given to be 19, while the 15th term is given to be 43. That is what the question tells us here. The 7th term is given as 19, while the 15th term is given to be 43. Now, we can now, for us to solve this question, we have to look at that particular sequence formula given to us. Tn is equal to a plus bn. We are asked to find these two variables, a and b. Now, for the T7 now, for the 7th term, is equal to a plus, don't forget that n is equal to number of terms. Now, we are talking about the 7th term now. 7, that is because 7b, that is 7 times b, because n here is the number of terms, which is equal to what? Is equal to, has been given to us to be what? 19. So we are going to now consider this expression here. We call this equation 1. For the T15, a plus, what is going to be the value of our n here? That will be 15b. That is 15 times b. That's n times b is equal to, what is the value given to us as the 15th term? 43. We take this as our second term, second equation. Now, after we've gotten the first and the second equation in that order like that, we will now look at it. If you look at this question very well, you will discover that it is alike a simultaneous equation. You know, whenever we are trying to solve any mathematics question, you have to make sure that you are always take into consideration all the topics that has to do with mathematics, starting from indices. Now, in this case here, this one is alike of simultaneous equation. And how do we solve simultaneous equation? We can make use of elimination method. We can make use of substitution method to solve simultaneous equation, because in simultaneous equation we are interested in finding the two values that are variables. When the two values are variable, you have to apply simultaneous equation. If it's only one value that is a variable there, you just use your linear equation in solving such a question, because linear equation is just a straight forward straight line equation that you use to get your answer easily. Now in this case now, I'm going to make use of what we call the elimination method by saying subtract, because I know that I am having the same value of the a in the first term and the first equation and the second equation. You can see that I'm having only one a here, but it is this b, that is, we have 7b here, we have 15b here. Because I'm having equal value of a, I can quickly remove it. But if I'm not having equal value of a, I have to apply my substitution method very well. By doing what? Look at the coefficient of the values there, then multiply this equation the first equation by the coefficient of the one I want to eliminate here, and multiply this one by the coefficient of the one I want to eliminate here. Take a look at our simultaneous equation lectures. You'll be able to get detailed information as regard that. Now, subtract equation 1 from 2. Why do I do this? Is that because I want to have a positive value for my b. Okay, let me go ahead doing that. So if I now say, whichever way I even go through it, I'm going to have a positive value for it. If I even say, okay, subtract this from this, or from this from this, I have the same very good value for it. So a minus a will be equal to 0. So we have been able to eliminate a here now. That's why we call it elimination method. Then 15 minus 7, that will be equal to 8b, will be equal to 43 minus 19. 43 minus 19 will give us 24. 24. Where we can now say that divide both sides by what? Divide both sides by, what is that value that is disturbing our b here? That's what? 8. That's the coefficient of b. That's what? By 8. That'll be 8b over 8 equal to 24 over 8. So where b will be equal to 3. That is the value of our b in this expression here. Having gotten the value of our b, it is easy for us to get the value of our a. What do? What we do here is just to look at any of these two equations that we have here. You can take any one of it, then you substitute the value of b at where you have the b, then you'll be able to get the value of your a with ease. Okay, I want to go into that substitution now by substituting it into the first equation first. So substitute 3 for b in equation 1. I'm going to have whenever I see b now, I put 3 there. A plus 7 multiplied by 3 is equal to what? 19. So you have a plus 21. 7 times 3, we know it's going to be equal to 21. It's equal to 19. So what do you do here is to subtract 21 from both sides in order for us to eliminate this 21 as well. A plus 21 minus 21 is equal to 19 minus 21. You can see what happened to this left hand side of this equation here. The same thing happened to the right hand side. Good. So we have a plus 21 minus 21 will give us 0 is equal to 19 minus 21. That will be equal to minus 2. The same thing when you try to make use of this particular second equation here from equation 2 now. If we make use of this equation 2 here now, you put b as what? 3, substitute 3 for b in that same equation. We are having a plus 15 multiplied by 3 is equal to 43. That is what that equation tells us. Now, a plus 15 times 3, that will be equal to 45. 45 is equal to 43. So when we have this added to a here, and we want to find only the value of a, we know that we are going to subtract from both sides what? 45. You can say subtract 45 from both sides. We are having a plus 45 minus 45 is equal to 43 minus 45. 45 minus 45, you cancel each other out. So A is equal to 43 minus 45, that will be equal to minus 2. You can see that we are able to get the same value for A when we substitute 3 for B in each of the equations. So whichever one you make use of, you are going to get the same value for that A as well. Thanks for taking part of this class. We implore you to subscribe to our channel for you to be able to have access to all our lectures. The arithmetic progression and geometric progression is coming your way soon. Please do stay tuned for superb lecture on it. Thanks and God bless.